Hello, I am Ian Fuchin, the lecturer for this course. In this session, I will demonstrate on-site how to test the pressure of an indoor fire hydrant using an actual unit and testing equipment. What we see now is the fire hydrant system water test inspection device, also known as the fire hydrant pressure measuring connector, which is primarily used to measure both the static water pressure and the dynamic water pressure of indoor fire hydrants. Static water pressure refers to the pressure at a specific point in the fire water supply network when the water is at rest. It is simply called static pressure. Dynamic water pressure is defined as the difference between the total pressure and the velocity pressure at a specific point in the fire water supply network when the water is flowing. It is abbreviated as dynamic pressure. Technical code for fire water supply and fire hydrant systems. GB 50974-2014 clearly specifies the requirements for fire hydrant pressure, specifically the requirements for static pressure. As you can see, the static water pressure at the most unfavorable points varies among different buildings, and we must adhere strictly to these standards. The code also includes provisions for dynamic pressure. The following outlines the requirements for dynamic pressure. Therefore, we need to regularly test the pressure of indoor fire hydrants at various locations to determine whether they meet the code requirements, ensuring strict compliance and eliminating potential fire hazards. Next, I will demonstrate how to test the static water pressure of an indoor fire hydrant. Please study attentively and pay close attention to every detail. First, check that the pressure gauge is securely tightened to ensure that no water leakage occurs during the pressure measurement. Second, connect the water test inspection device to the outlet of the indoor fire hydrant. Ensure that when installing the device, the pressure gauge is positioned vertically upwards to facilitate accurate readings. Then, close the water outlet valve on the test inspection device to maintain a sealed system. Next, slowly open the fire hydrant valve fully. Once the pressure gauge reading stabilizes, the displayed value represents the static water pressure at the hydrant outlet. The current static pressure is 0.27 megapascal. Finally, disassemble the setup. After the measurement is complete, close the fire hydrant valve. Loosen the pressure gauge connection. Open the water outlet valve to release the pressure from the test device, and then remove the device. Now, let us learn the method for testing the dynamic pressure of an indoor fire hydrant. First, connect the hose, unroll and straighten it, and attach one end to the fire hydrant outlet. During the connection, align the hose's clip with the corresponding clip on the hydrant outlet. Then twist in a clockwise direction until you hear a click, indicating a successful connection. Next, connect the other end of the hose to the inlet of the test inspection device. Then, slowly open the water outlet valve on the test inspection device, followed by the fire hydrant valve. Once the water flow stabilizes, the water pressure displayed on the device's pressure gauge is the dynamic pressure at the hydrant outlet. The current dynamic pressure is 0.12 megapascal. Finally, after the measurement is completed, close the fire hydrant valve. Remove the test inspection device. Detach the hose and drain any remaining water from the hose so that it can be air-dried. In this session, we learned how to test both the static and dynamic pressures of indoor fire hydrants. After obtaining the actual data, you must compare the results with the code requirements, maintain proper inspection records, and draw appropriate conclusions. Since the indoor fire hydrant system is one of the most common fire extinguishing systems within buildings, conducting regular pressure checks is standard practice. I hope that you will master these operational steps and effectively apply what you have learned in your future work.